Whoever looked at a wall thousands of years ago and added the first hole to let some light in sure was onto something. Windows are amazing, even if I personally cannot live without my blackout curtains. And window technology has made some major advances over the millennia, like adding screens to keep bugs out or double glazing to keep heat in. But I think it's pretty clear. Scientists have yet to perfect windows. The main challenge these days is to create something super energy efficient. Something that doesn't force us to use a bunch of electricity to keep a building's insides the ideal temperature. But boy, are scientists creating some nifty solutions. Here are 5 futuristic windows that may be coming to a wall near you. If you let sunlight in through a window, you also let heat in. Sometimes that's great, like when you've built a greenhouse or it's winter in the American Midwest. And sometimes that's the opposite of great, like when it's summer in the American Midwest. One technique you can use to block some of the heat is to put a film on the glass. It keeps heat out and uses a lot less energy to keep rooms cool, making buildings much more energy efficient. But while we've been slapping films on windows since at least the 1960s, there's one problem in the R&D of it all that keeps sticking around. In laboratories, a lot of films are optimized for a 90-degree angle of incidence. That means they'll block the most light and heat when light comes at them perfectly perpendicular to the window pane. The sun, you may have noticed, is rarely beaming light into a building at that angle. For most of the day, especially when it's the hottest part of the day, all that light is hitting your typical vertical window at a very sharp angle. If you've optimized your film for light to hit at 90 degrees, it's gonna be performing near its worst right when you need it the most. So a paper published in 2024 goes into how one team went ahead and designed a film that works great at a whole bunch of angles. In other words, as the sun's position changes over the course of a day, it requires a series of different layers, placed in a specific order determined by some quantum computer-assisted modeling. Each layer has a unique refractive index, meaning it bends the light that enters or exits it by a certain amount. So, by stacking those layers on top of each other, the scientists were able to fine-tune just how the light bounced and keep out as much heat over as many sun angles as possible. When the team tested their film on vertical windows outside, it reduced temperatures on the other side of the glass by up to 5.4 degrees Celsius. Although I should note that's compared to a naked pane of normal glass, not one covered in standard commercial film. As for when you want to keep the air inside nice and toasty, well, let's turn to our next innovation: vacuum seals. No, I don't mean a cavalry of cute marine mammals riding Roombas, but I like where your creativity took you. If you want to transfer some heat, you can do so one of 3 ways: conduction, basically direct contact; convection, basically the mass movement of a fluid like water or air, like how your oven works; and radiation, basically traveling through space as energy waves and warming things when they absorb them. So if you want a window to avoid transferring heat, you could try preventing at least one, if not more, of these methods from working. For example, the company Luxwall has created what they call transparent insulation. The basic structure comprises 2 planes of tempered glass with sand grain-sized structural micropillars that keep the panes from touching. They're similar to dual pane windows in that they use 2 glass panes, but instead of air or some other gas sandwich between them, there's nothing. It's a vacuum, or as near a vacuum you're able to get. Each window has a little evacuation port in the corner to suck all the air out, and to capture any stray molecules left bouncing around between the panes and create an even stronger vacuum, these windows also feature what engineers call a thin film getter. Yes, that's a real term you can read in academic papers. I know, it's terrible. With practically no molecules between the panes, remember gases are technically fluids, there's no opportunity for convection. And with nothing between the glass panes besides those structural micropillars, there's basically no chance of conduction. That leaves just radiation as a viable method of heat transfer, and Luxwall has added a low-emission coating to block a lot of that, too. Now, technically, the idea to use vacuum insulation in windows is far from new. A German patent titled hollow glass pane, except, in German, dates all the way back to 1913. and commercial products have been around since the 90s. But until recently, there were limited applications. The windows were too expensive and didn't hold their vacuum long enough for it to be worth it for most buyers. Thanks to innovations across the fields of physics, ceramics, material science, and manufacturing automation, that's starting to change. But maybe the future of windows doesn't involve glass at all, vacuum insulated or otherwise. Because scientists are also on the hunt for new materials to make their windows out of. And one team has decided to work with wood. Not in a board up your windows way either. This is fancy see-through wood. Why wood? Well, one reason goes back to the don't let heat in thing. Wood is about 25 times better at trapping heat than glass, so some scientists have been experimenting with ways to make it clear enough to peer through in the hopes of finding a cool window alternative. Wood at a basic level is made up of 3 main molecules: cellulose, hemicellulose, and lignin. There's also water and some impurities, but that's the most important stuff. And if you do the right chemical reactions to remove or depigment the lignin, you can get a relatively transparent result, especially if you fill it with something like clear epoxy. However, epoxy comes with its own problems, like not being biodegradable. So in a paper published in 2025, one team from Kennesaw State University in Georgia set out to make an eco-friendly alternative. Inspired by the use of egg whites as building materials in ancient India, the team used sodium sulfite to strip balsa wood down to what's basically a lignin-free cellulose skeleton. Then they filled the holes in that skeleton with a mix of rice extract and egg whites. Voila! A sort of clear window. I know being only semi-transparent and brownish isn't ideal, but it's a start. Meanwhile, if you're not a fan of balsa wood, you could try bamboo, which I know isn't wood, it's grass, but it feels similar, and it's made of most of the same basic chemical compounds, so it's worth a mention. And turning it into windows is a very similar process. Remove lignin from plant, make remaining structure strong enough to stand on its own. The researchers behind this experiment soaked bamboo in an acid until all the lignin was gone. But to make it strong, they didn't fill the gaps in. They just smushed the bamboo down until it became a thin, flexible, whitish material. So our bamboo window also isn't clear. But hey, at least frosted glass windows are a thing. Plant-based windows may not let all the light in that you might want, but with more sophisticated materials, researchers are also inventing window panes that can change how much light gets let in. In 2025, a team from the Korea Advanced Institute of Science and Technology published their research on electrochromic tints. They're made of molecules that change color when subjected to electricity. To support the flow of that electricity, the windows have 3 main components: an outer layer of glass, an inner layer featuring an electrochromic chemical called Prussian white, and in the middle, an electrochromic gel filled with dissolved silver. Each window pane also has 3 modes. Mode number 1 is clear. It just lets all the light through like a regular window. Mode number 2 is what the researchers called colored. By sending electricity through the setup, a chemical reaction turns the Prussian white into Prussian blue. The new blue color blocks a bunch of both visible and infrared light, but not all of it. So everything inside is a bit less illuminated, but it stays colder. Finally, there's mode number 3, reflecto mode. When a more powerful electric signal gets applied, the silver basically undissolves out of the gel and turns into a mirror, reflecting pretty much all light and heat to keep the room extra cool. And the best part? All of these changes are reversible. Turn off the electricity and you go right back to clear. Meanwhile, another team has used a mix of plain old water and tungsten oxide to create their own 3-mode dynamic window. Tungsten oxide is also an electrochromic material, like the previous team's Prussian white, but by itself it only has 2 modes, clear and dark. To get an in-between, the team added some water to create tungsten oxide hydrate. The resulting hydrate did not become a perfectly tunable window. You can't tune it like a light on a dimmer. But with the right amount of electricity, it could let visible light through while blocking infrared. It may not make your living room as cold as the dark depths of the sea, but hey, you can only ask so much from a few water molecules. And that's not even the liquidiest that cutting-edge windows get. In 2023, researchers at the University of Toronto created a prototype full of channels through which they could pump different liquids to give their window different properties. The whole system was inspired by the color-changing skin of squids. In one experiment, they made a tiny room with their prototype window on one side, lit that room from the outside with a 100-watt light bulb, and measured the internal temperature of the test room. Once it got up to 39 degrees Celsius, the team used a syringe to add a specially prepared fluid that included little particles of carbon. Those particles would float around and block some of the light from the bulb, cooling down the room. In fact, the room got down to 32 degrees in just 15 minutes, without the carbon blocking much visible light. In theory, you could stack layers of these liquid-filled window panes together to block out even more light at a given time. Like layer 1 with fluid 1 blocks infrared light, layer 2 with fluid 2 blocks some visible light, and so on. Even more in theory, the researchers eventually want to replace the currently manual controls with a fancy computer program that would learn what a specific window's needs are over time and then adjust itself throughout the day to let the ideal amounts of right wavelengths of light in. All, of course, to keep those energy bills low. But personally, I think their stretch goal should be to make windows shaped like squids. There has to be some kind of seafood restaurant that would buy them, or an independently wealthy toothologist. Did you know that's what they call people who study squids? Because I sure didn't. As helpful as they've been to human civilizations, Windows could still use an update or two, maybe 5. And thankfully, scientists are on top of it. Some innovations are ready for purchase and can continue to be improved. Some are still solidly in the R&D phase. Personally, my favorite is the squashed down bamboo frosted windows, but let me know when they make a window that can replace my blackout curtains. Support for this episode was provided by Breakthrough Energy.